this is Mrs. Often. We're back with more information about angles formed by parallel lines and transversals. In this section, we will be looking at application problems involving angles formed by parallel lines and transversals, and we'll also discuss the special properties of angles that are formed when two parallel lines are cut by a transversal. Some helpful hints. Segments or rays are parallel, perpendicular, or skew if the lines that contain them are parallel, perpendicular, or skew. And to determine which line is a transversal for a given angle pair, locate the line that connects the vertices of all angles shown in the diagram. We begin with the same side interior angles postulate. This is actually the contrapositive of Euclid's fifth postulate. It says that if two lines are parallel, then the same side interior angles are supplementary. Please note that we must know that the lines are parallel to use this postulate. We can use it here because both lines P and Q have the little arrowhead to show that they are parallel lines. We will abbreviate this postulate as PSSIS. If lines are parallel, then same side interior angles are supplementary. Here is one example. Please note that lines L and M are parallel to each other and transversal T is crossing them. We'll use the same side interior supplements postulate to show that to determine the value of x and the measure of each angle. So I begin by writing the equation 3x plus x plus 72 equals 180 using PSSIS. I simplify by combining like terms. I then subtract to get 4x equals 108 and divide by 4 to obtain that x is equal to 27. I can then substitute to determine the measure of both of the angles. By substitution, my x plus 72 angle is 99 degrees, and my 3x angle is 81 degrees, and we can see that these are in fact supplementary. Remember that postulates are statements that are accepted without proof. And since the same side interior angles postulate is given as a postulate, it can be used to prove the next three theorems that we will see. We have the alternate interior angles theorem, PAI. If parallel, then alternate interior angles are congruent. If two parallel lines are cut by a transversal, then the two pairs of alternate interior angles are congruent. We can see from this diagram by the arrowheads that the lines are parallel. Therefore, angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. Our next theorem is the alternate exterior angles theorem, which we will abbreviate PAE. If two lines are parallel, then the alternate exterior angles are congruent. And this is when two parallel lines are cut by a transversal that the two pairs of alternate exterior angles are congruent. We can list these as angles 5 and 7, which are congruent to each other, and angle 6 is congruent to angle 8, as seen here. Finally, the corresponding angles theorem. If two parallel lines are cut by a transversal, then the four pairs of corresponding angles are congruent. And we can again see that lines P and Q are parallel and are labeled as such. This means that angle 1 is congruent to angle 3, angle 2 is congruent to angle 4, angle 5 is congruent to angle 7, and angle 6 is congruent to angle 8. And my apologies, I was not able to get the regular congruent symbol. Please use the symbol that is the equal sign with the tilde above it to demonstrate congruence. Finally, another theorem, if a transversal is perpendicular to two parallel lines, all 8 angles are congruent. That's P to P, 8AC. Here in example 2, we have that AB is parallel to CD. Now, since AD is parallel to CD, we can see that this angle 3x squared plus 4x must be congruent to the angle which makes a linear pair with 8x. This allows us to write the equation 3x squared plus 4x plus 8x equals 180 degrees. Combining like terms gives us 3x squared plus 12x equals 180. We subtract 180 from both sides. I factored out 3 to make this a little bit easier to factor. There are our factors. This yields x equals negative 10 or x equals 6. However, we can see that by substitution, we would get negative 80 degrees, and that would not work out for our angle. So that means that negative 10 is an extraneous solution, and the only value of x that works is x equals 6. Here's another application. We have multiple parallel lines that are crossed by transversals, and we have some pairs of congruent angles. There's one pair, and here's another pair. In blue, we have alternate exterior angles, and in red, we have corresponding angles. So we see that 2x plus 5y is equal to 125, and 2x plus 4y equals 120. Now, fortunately, it's pretty easy to subtract these two equations to solve this system rapidly. We get y is 5, and then by substitution, we can obtain our answer. During class, you will work in your group to prove your assigned theorem, whether that's the corresponding angles congruence theorem, alternate exterior angles, alternate interior angles, or that 8 congruent angles are formed when a pair of parallel lines is intersected by a transversal that is perpendicular to one of the lines. Groups will then be reorganized to share out their assigned proofs. I hope this video has been helpful to you. Have a great day.